Adolescence is a period of rapid growth and development, and emerging research is revealing that ultra-processed food, UPF, diets during this time may have profound consequences on gut health, with implications that extend far into adulthood. A recent study reports that adolescents consuming high amounts of UPFs exhibit significant reductions in gut microbial diversity, a critical marker of a healthy microbiome. This loss is more than a cosmetic change to bacterial populations. It represents a fundamental disruption in the systems that regulate metabolism, immunity, brain function, and overall resilience. The long-term health impacts could be severe, particularly given the persistence of microbiome patterns established during this formative period. The gut microbiome thrives on variety. A rich, diverse bacterial ecosystem helps the body break down complex carbohydrates, produce essential vitamins, maintain immune balance, and communicate with the brain through the gut-brain axis. Diets high in UPFs, however, are typically low in fiber, polyphenol, and other compounds necessary to nourish beneficial bacteria. Instead, they are loaded with refined sugars, emulsifiers, preservatives, and artificial additives, which create a hostile environment for healthy microbes. The result is a marked shift in microbial populations. Beneficial bacteria decline while less desirable species, some linked to inflammation and metabolic dysfunction, increase. Studies indicate that even relatively short-term exposure to UPF-heavy diets can reduce microbial richness and stability, weakening the gut's resilience and its ability to respond to dietary or environmental challenges. The long-term consequences of these microbiome shifts are striking. Reduced diversity is associated with a greater risk of obesity, insulin resistance, and type 2 diabetes, as the gut becomes less efficient at regulating energy extraction and metabolizing nutrients. Certain bacterial imbalances can trigger low-grade systemic inflammation, which has downstream effects on cardiovascular health, cognitive function, and mood regulation. Adolescents who habitually consume UPFs may unknowingly be setting the stage for chronic disease decades later, even if weight or caloric intake initially appear normal. Mental health may also be affected. The gut-brain axis relies on microbial signaling to support neurotransmitter synthesis, stress response, and emotional regulation. A less diverse microbiome can impair production of serotonin, GABA, and other mood-stabilizing compounds, potentially increasing vulnerability to anxiety, depression, and emotional dysregulation. Adolescence is already a period of heightened psychological sensitivity, so disruptions to gut microbial communities during this window may amplify the risk of mood disorders that persist into adulthood. The timing of exposure matters. Adolescence represents a window of opportunity when gut microbial communities are still adaptable and responsive to diet. Chronic reliance on UPFs during this period may solidify maladaptive microbial patterns, making it increasingly difficult to restore diversity later, even with improved diet. Once beneficial bacteria are lost or outcompete, their recovery may require prolonged dietary intervention, prebiotic and probiotic support, and sustained behavioral change, a challenge for many young people navigating busy school schedules, social pressures, and limited access to whole foods. Environmental factors exacerbate the problem. Schools, universities, and convenience-focused neighborhoods often provide ready access to UPFs, while minimally processed foods are less visible, more expensive, or more difficult to prepare. Marketing strategies reinforce the preference for flavor-engineered, ready-to-eat options, encouraging repeated exposure that compounds microbiome disruption. The combination of easy access, engineered taste, and low nutrient density creates a perfect storm for microbial impoverishment. The warning is clear and urgent. UPF diets in adolescents do not just influence calorie intake, they actively reshape the gut ecosystem, with cascading effects on metabolism, immunity, and emotional health. Reduced microbial diversity can alter energy balance, exacerbate inflammation, impair nutrient absorption, and increase susceptibility to chronic disease. These consequences may persist into adulthood, making early dietary habits a critical determinant of lifelong health. Protecting adolescent gut health requires more than individual willpower. It demands structural changes to food environments, education on microbiome-friendly diets, and policies that prioritize minimally processed foods rich in fiber, polyphenol, and micronutrients. Ignoring these signals risks creating a generation whose gut ecosystems, and by extension, metabolic and emotional resilience, have been compromised before they even reach adulthood. The hidden cost of convenience may be a lifetime of microbial imbalance, chronic inflammation, and increased disease vulnerability.